Hello everyone, welcome back to the session. In this video, let us try to understand the concept of hashing and what is the necessity of hashing and what makes hashing prioritized in the data structure subject. And let us also try to understand the concept of collision and how the collision occurs and how to resolve the collision as well. So first talking about the hashing. See, let us try to understand the problem first. If given an array, let us say you have an array of that's a fixed array, okay? That's a fixed array, and you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You have 10 cells in an array, and okay, let the length be 10, and the values are as followed: 7, 65, 3, 1, 2, 4, 9, 83, 81, 90. Okay, the values are as follows. If you were told to fetch a number from the array, let us say you have to fetch the number 83. How are you going to tackle this problem? You would simply use a for loop, go iterate from 0 to all the way to 9, and try to match the current value of I with the given element. This is G. If it matches, you would break. Okay. If you think about the time complexity, if the given G is at the first place, the time complexity would be O of 1. And if the given complexity is anywhere between 1 to 9, it will simply consume O of n time complexity. So we are going from unit complexity to linear complexity. So if the given element that is given for you to fetch is somewhere in between the second cell to nth cell, you are going to consume O of n time complexity. So in order to reduce this complexity, they have introduced hashing. So hashing is this a technology where insertion and deletion happen in O of 1. So it takes constant time. Okay, let us also talk about inserting an element. If you have to insert an element at if you have to insert an element, if you have to insert at specific position, maybe you need to use O of n, go linearly. But if you have to insert at the tail, then you would take O of 1. Okay, let's leave about this. Now let us try to understand what has hashing has brought to the table. So as I've said, we can insert in constant time. We can also search in constant time. We can also delete in constant time. So this is what the hashing, the technique or the methodology of hashing get to the table. It reduces the time complexity from O of n to O of 1 constant time. And how is this possible? This is simply possible by using a mod function, a modular function. So we use mod function. And let me brief you about this mod function. Let us say x1 mod x2. Okay. So what happens is, mod is just this operator on the keyboard. So this will produce the reminder. So generally on division, what the operator outputs is the quotient basically. So when you use the modular operation, it will produce the result, the remainder as the result of that particular operation. So you need to use the mod operation, and I'll show you practically how to use this. So let us say we have a fixed array. Let us say we have a fixed array of length 10, just to keep it simple. 0, 1, 2, 3, 4, 5, 8, 9. Okay. Now okay, because the length of this array is 10, let us assume our x2 to be 10. I am assuming x2 to be 10 because of the maximum magnitude that is given. So the maximum magnitude in this example is 10. So I am assuming my x2 to be 10. That's simple. Now if you are given an element, let us say 83. Let us say you are given an element 83, and now what you simply have to do is just have to calculate 83 mod 10. So to calculate this, just use your Chrome extension. 83 mod 10. It has given 3. Okay, so the result is 3. Because the result is 3, you can simply use this 3 as the insertion index. So just simply okay, let us name this array as ARR. So just do this equal to 83. So the formula will look like ARR of x1 mod x2 equal to x1, which is the element itself. Clear? This is the formula. So on calculating, the 83 got inserted at this position. Okay. Now, if you are given another element, let us say, okay, let us have 25. And how to calculate the formula? You have to just do 25 mod 10. So here 25 mod 10, that's 5. So use this 5 as the insertion index and just insert 25 at this position. So you keep on inserting elements in this way. So on insertion, the time that you have the CPU has consumed is constant time. And if I say to you to fetch a specific number, if I say fetch 25, you need not need to search the array linearly and try to fetch the array. Simply reverse engineer this formula, because see, because 25 is an element that is already stored in the array, just compute the mod by the length of the array, which is 10, and you would get 5 as the index. So simply go to the index 5 and fetch out the number. So if I tell you to return the index of that particular number, you would just return 5. If I tell you to retrieve 83, you would simply calculate, reverse engineer this formula. 83 mod 10, that's equals to 3, and you just got the position of the particular element. So in this way, we have reduced the time complexity from O of n to O of 1. Now everything was fine until this point, but if you think there's a small issue or a major issue, it can be a major issue. What if you get another element, let us say like 50. Okay, I've given you the element 50 and told you to insert in this particular hash, or okay, let's call this an array for now. So you would simply compute 50 mod 10 and you would get 5. But when you notice, okay, if you follow this rule, you would simply rewrite this position with the new element, that is 50. But here is the problem. If you rewrite the element, what about the previous element that I have stored? First I have stored 83, then I have stored 25, then I have stored 50. But in the array there are only 2 values present, whereas I have stored 3 values, but only 2 values are present in the array. This is the inconsistency that we are getting to observe in this problem. So how to tackle this problem? So for this reason, they have introduced chaining of linked list. So simply what they do is, whenever you have this kind of problem, you will not erase the data. If you have the data present in a particular cell, you will chain that particular cell with a linked list. So that would become something like, so just remember this formula. So that would become like a linked list. Okay, so in that linked list, as we have discussed in the class, it has the data as well as the address. So it looks something like let us say 50, and this will be null for now. And if I give you another element which is 75, maybe I gave you 75, and you would simply compute 75 mod 10, that would give you 5. So next thing what you would do is come to this position, index 5, and you will notice that there's an element already present. So when the element is present, you need to traverse through the chained linked list, and then from here you get to this point and you reference the current node to another node. So this won't be null anymore, it will be 75, and this will be null, and this will point to this address. So this is how you chain each and every cell in the given array. Now here's another problem. Let us assume that you have some m elements, little m elements in this particular chain. Now you have to search for this element. Let us say this element is some 85. You have used O of 1 time complexity to reach to this position. Okay, that was fine. But because here there's a chain of linked lists, again you will have to consume O of n time complexity, because you need to search everything in a linear fashion. Now this is another problem. How to tackle with this problem? Researchers have thought so much on this and have come up with an idea by balancing this particular chain. So instead of maintaining a long chain, what they have done is they have used a binary tree, probably a self-balancing binary tree, that would make this time complexity to reduce to n log n. So instead of n log n is a better time complexity compared to n. So this could not be reduced anymore, because that's the only solution for the given problem. So if you can think any better solution, then try to comment down on this video. Okay, I hope you understood.